intuition, but it wasn't a match.
Today I'm going to be talking about Pascal's Triangle. Now, Pascal is a man. The guy who came up with Pascal's Triangle his last name is Pascal, something like that. And he was some smart kid or a prodigy, whatever. When he was young, like a teenager, he was actually starting to build his own calculator machines. That's what he was trying to do. In 1653, Pascal made his Pascal's Triangle, or table of binomial coefficients. So let me show you guys what that looks like. Let's start off with the binomial x plus y to the power of 4. So to FOIL this, it would be x plus y times x plus y times x plus y 4 times. And then
distributing, I think, right, be x squared plus 2xy plus y squared times, I don't know if you guys can read this, x squared plus 2xy again plus y squared, and then it would get really long, so start off with x4, or x to the power 4 plus 2x to the power 3y plus 2x3y plus 2x, or 4x 3y to the power 2 plus 2xy 3 plus y 2x2 plus 2xy to the power 3 plus 4, or plus whatever. This is really long. And then that would become x to the power 4 plus 4x to the power 3 y plus 6x to the power 2 y to the power 2 plus 4x times y to the power 3 plus y to the 4th. And that would all become
x to the power 4 plus 4x to the power 3y plus 6x to the power of 2 y to the power of 2 plus 4x y to the power of 3 plus y to the power of 4. And that would be the answer. That would be the answer to FOILing out x plus y to the power of 4. So you might be thinking that was like the longest thing ever and I just wasted a minute. Well, there is a faster way to do this. So if we take a look at Pascal's Triangle, let me show you guys what that actually looks like. We have a new piece of paper right here, and I'll start writing it out. So Pascal's Triangle looks like this. We have a 1, it starts with 1, and then it gets followed by a 1 and a 1, and then a 1, a 2, and a 1, a 1, 3, 3, 1, a 1, 4, 6, 4, 1, a 1, 5, 10, 10, 5, 1, and so on. So this is Pascal's Triangle, and before you're like, what the hell does that mean? Let me explain. So using this information, we can actually figure out the binomial coefficients for when we factored this binomial x plus y to the power 4 by simply looking at what our coefficients are for each one of these. As you can see, the numbers that correspond to our answer, we can find them inside the triangle. So first of all, let me show you guys something. If we have x plus y to the power of 4, and this goes with any binomial to the power of whatever, it can be written out as, let's make this an x to the power of 4, because we're doing to the power of 4, plus x to the power of 3 to the y plus x to the power of 2 times y to the power of 2 plus x to the power of 3, and then finally y to the power of 4. So what just happened was, when you're going left to right, the x's will always go from x to the power of 4, starting, as you can see, for x to the power of 4, and then it goes to x to the power of 3 times the y, then x to the power of 2 times y to the power of 2, and basically the y and the x are switching how many times it's being powered. So going from right to left, it's y to the power of 4, then y to the power of 3 times x, then y2 and x2 to the power of 2, y and x to the power of 3, and then finally x to the power of 4. So it's almost, x is getting lower when it goes to the right, and y is also losing numbers, or its powers, when it's going to the left. So we can write that out. We can just write x plus y to the power of 4 as this. And what that teaches us is, well, that's basically, if we get our old paper back, that's basically these numbers right here, x to the power of 4, x to the power of 3 times y, x squared times y squared, x times y to the power of 3, and y to the power of 4. It's the same thing after we FOILed it as it is on here. Now, if we go back here, you can see that these numbers are here, and we don't have those numbers in this equation because we haven't finished it. If we look at this triangle, you'll understand that this row right here, because it's being the fourth power, because this is x plus y to the power of 4, we can look at Pascal's triangle, and we can look at the fourth row. Now, the rows start from this row right here. This is row number 1. And the reason why is that because this one right here is just like to the power of 0. It's just something, or I think it's 1 to the power of 0. So it's just 1. So we have row 1 starting actually at this row, row 2, row 3, and row 4. And because x plus y is being powered by 4, we can look at the fourth row and see that 1, it starts with 1 and then goes to 4, 6, 4, 1. And all we have to do is plug it in to this equation, which becomes 1 x4, or just x4, x3. Well, we have an x3, so we're going to just plug in the next value, which is 4, x3y, plus next value 6, so we're going to put 6 right there, x squared plus, or no, not plus, but y squared plus 4, the next value is 4, so we'll put 4 there, 4x y third, and then finally it's another 1, so we could just write out the 1, I guess, and have it 1 y4, and then you can see that, let me just write this out real quick, 4x3y plus 6x2y squared plus 4x y, boom. That answer right there is the same one as this answer. So using Pascal's triangle, we have done x plus y to the power of 4 without foiling it at all. All we have to do is look at the rows to get our answer. There is also something called the Binomial Theorem, which says that for any power for x plus y, that power will match up with the row in Pascal's triangle. So if we have x plus y to the power of 7, then if we go to the 7th row of Pascal's triangle, it will show the coefficients that match up if you had FOILed the entire binomial. So let's talk about how the Pascal triangle can be applied to real life, because right now it's just a triangle with numbers, and there's no real science or anything that really helps me personally. Like, I don't care. I don't know what this can be used for, but we can take a look at statistics. I'm not in statistics. I am in algebra, or I'm in trig right now. So I had to do my research, and there are things like your height and your weight and IQ scores and growth rates and all this other stuff on how, basically, if we talk about a graph, and specifically the bell curve, which is it's a graph that looks like this, and I'll put a picture up, but it shows that in average, multiple studies show that lower performers in like things like weight and height or IQ scores will be at the bottom of the bell curve, and then average humans with average IQ scores will reach the top of the bell curve or the vertex, and then the highest performers who are rarer will also go back down to the other side of the bell curve. So that's what the bell curve is. It's used in a lot of statistics and a lot of stuff like that. There's even a book, I believe, written about it called The Bell Curve, and it was about intelligence and IQ scores and how it proves that people at the top of the IQ score did way better in life, while people at the bottom of the IQ score did way worse, and then people in the average did pretty much, the same, I guess you could say. And just how the bell curve is a real thing in statistics and how it can actually be applied to many things. The same thing applies to Pascal's triangle. If we go down the rows of Pascal's triangle, the numbers in the middle become exponentially almost greater than the numbers on the outside. While the numbers on the outside remain low, they're like in the dozens and stuff. And if you get to like the 20s, those numbers in the middle are at the thousands already, while the numbers on the outsides are still at only 20 or whatever. They remain low on the outside because it's just like the bell curve, as how on the top you have the most people, in the middle the average, while on the sides you have lower numbers. So the Pascal triangle has the same exact bell curve seen in many statistics. So that was 13 minutes of video. What did I learn from doing this research for the Pascal triangle? It was really fun. I spent a couple days in class, actually, in my other classes, just writing my essay, because I am writing also an essay for this project for my math teacher. There are a few other examples in that essay, but I really enjoyed talking about this Pascal triangle because I didn't know what it was until like 3 days ago. And I think it would have been useful last year in Algebra 2. But I don't think we learned it. My teacher didn't teach us it. But it's really cool how it correlates with the statistics, and like it actually connects with real life stuff that you learn in other things. It's really cool. So yeah, like hopefully you understand how to do it now, or understand what it is, how it works. That's why this video is so long, because I wanted to make sure that it was understandable. But if it's not, then leave a comment, hit the subscribe button, all that good stuff. You guys want to watch some daily Minecraft videos like this one? Subscribe. Follow me on Twitter, Twitch, the other one. Go fund me. Everybody go fund me. Make sure to follow me on Instagram and Facebook and MySpace and Amazon. Hit that download link. Hope you guys enjoyed the video, liked the video, subscribe to my channel, and goodbye.